The last lesson we looked at the greatest common factor. Now we move on to different patterns. The first type is looking at the difference of squares, meaning we kind of need to know what our perfect squares are. So I've listed some common ones you really should know. Let's just fill this out. How are you doing? Keep going. Hopefully you know up to 10 times 10. Now the other ones after this, you're just going to need to start learning. 11 squared is 121. 12 squared, 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. And I'll be honest with you, we'll try to keep with the smaller numbers, but these are some common squares that you're going to see. You should try to familiarize yourself with them. Another thing we need to review is something we learned a few lessons ago when we were multiplying, and we multiplied conjugates. Remember, conjugates are binomials that look exactly the same except the middle sign is different. And do you remember the pattern when we multiplied? Well, if we just FOILed it, first, out, inner, last, remember those middle terms canceled, and you just got the first term squared and the last term squared. Today, we're going to go backwards. So this is what's called the difference of two squares. Difference meaning minus sign, and of course, we have two perfect squares that are subtracted. Alright, so if I multiply this, let's do it the fast way. We would multiply the first one, so 7 times 7 is 49, and we'd have x squared. Then we'd have minus 36. So again, we have the difference of two squares, a minus sign, and then two perfect squares. And that came from multiplying conjugates. So today we're going to learn how to factor what's called the difference of two squares. You have to recognize that there are two squares with a minus sign between them, and only a minus sign. Then we're going to factor it with two binomial conjugates. They're very easy, but you've got to recognize that pattern. So let's look at number 1. Do we have the difference of two squares? Yes, I have a minus and two squares. So I'm going to have two parentheses. X times x is x squared. 5 times 5 is 25. And then the conjugates, meaning we need to have different signs in the middle. You can check your work by multiplying that back out, and we would get x squared minus 25. Very easy. Number 2. Do we have the difference of two squares? Is that a minus sign? Yes, we do. So two parentheses, the 49 comes first, so 7 times 7 needs to come first in your parenthesis. Then y times y, one's a plus, one's a minus. It doesn't matter if you put the minus and then the plus, as long as they are different, because remember, we want them to be those conjugates. Look at the third one. We have the difference of two perfect squares. So 64x squared. 8x times 8x is 64x squared. 3y times 3y is 9y squared. And then we need that conjugate part, that plus and then minus. Number 4. Is that the difference of two squares? No. Is there a GCF? No. So we would call this prime, meaning it's reduced down as far as possible. That is called prime. It cannot be factored. Number 5. Well, I have a minus sign. That's a perfect square, but 12. 12 is not on my list of perfect squares. Look at the top of the paper. That is not a perfect square. So again, there is no greatest common factor. It is not the difference of two squares. We can't do anything with it. So we would say that is prime. Now we're going to combine the last lesson with this lesson. So we're going to look for a GCF. We're going to look for squares. So number 6. So reviewing the last lesson. Do they have a number in common? Can 7 and 28 both be divided by a number? Yes, 7. So I divide them both by 7 because they don't have any letters in common, and that would leave me x squared minus 4. Now I look at that and ask myself, is that the difference of two squares? Yes, it is. So on the next line of your notebook paper, you're going to carry down the 7, then you're going to factor x squared minus 4 as the difference of two squares. So x times x is x squared, 2 times 2 is 4, and then make them conjugates. I do not want to just see that answer. It's 2 steps. We have the GCF first and then factor more. Number 7. Do we have a GCF? Well, hopefully you know if it's divisible by 5, it either ends in a 5 or 0. So 5 does go into 180, but they also have an x in common. So I'm going to divide both of them by 5x. So that leaves me x squared minus, the x's cancel. Let's see, 5 goes into 18 3 times, I think that's 36. Is that the difference of two squares? Yes, it is. So on the next line of notebook paper, we're bringing down our GCF. Now we're factoring our squares, making them conjugates. 2-step process. You cannot skip that step. I will take off points. Let's look at number 8. You're saying, but it's a plus sign, can't do anything. And I'm going to say, be careful. Does it have a GCF? Yes, it does. They're both divisible by 9. So we can divide both of them by 9. Then we say, can we keep going? No, because that's prime. We can't go any farther. So that's our answer. So that is the answer that is not prime because we did factor it. We did have a greatest common factor. Look at number 9. We have an x to the 4th. We have a minus. We have a 16. Are those the difference of two squares? Yes, it is. So what times what is x to the 4th? X squared times x squared. And 16 is 4 times 4, and of course we need a plus and a minus for those conjugates. Can we keep going? Well, let's see. That is the sum of two squares, so no, you can't do anything with that. But this is the difference of two squares, and I can keep going. So I'm bringing this one down because I can't do anything with it, but this one, I'm factoring it further as the difference of two squares. Again, those conjugates. That is a 2-step process. Again, I want to see both steps. First line of paper, second line of paper. Now let's just do some practice problems. On this one, do we have the difference of two squares? Yes, we do. 2x times 2x is 4x squared. Y times y is y squared. And we need a plus and a minus. No GCF, that's one step, you're done. Number 11, do we have a GCF? No. Is it the difference of two squares? Yes. So 11x times 11x is 11x squared. Then 10y times 10y is 100y squared. We could have a minus and then a plus. I know I've been usually putting plus and a minus. I thought I'd mix it up a little bit. Are you getting it? I hope so. This one's pretty easy. Number 12. Is there a GCF? You've always got to be thinking that very first thought. Yes, they're both divisible by 3. So if I divide both of those by 3, I would leave 4x squared minus 9y squared. Then you ask yourself, can you factor more? Yes, I can. It's the difference of two squares. So again, 2 steps because I did the GCF first, then I did the squares. 2 steps. I want to see both steps on your paper. Number 13, again I do see a plus sign, but is there a greatest common factor? Yes, they're both divisible by 4 and they both have an x. So if I divide them both by 4x, that would leave me x squared plus 4. Can I go further? No, I cannot. That's my answer. Again, not prime because I did take out a GCF. Then I have a challenge problem for you. It has more than 2 steps. See what you can do with it.